Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India. On this day, December 29th, 2021, Wednesday, 3:40 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक 29/2021 दिसंबर 2021 सुबह के 3:41 and presenting to you same talk regarding quality, safety and engineering issues and public issues. Title being same, civil field engineering. Civil is there, field engineering, life engineers and concrete specifications. System of quality and quality itself, of course contracts, designs related construction and construction related designs, methods, contracts, and of course when there are contracts there must be certain kinds of disputes possibly, and you can say always applicable communication and coordination for everyone. We can say that this is my identification address, my name, my professional enroll titles and my email ID. You can see this email ID here, Suraj underscore engineer at yahoo.co.uk. I am currently resident of Faridabad, NCR, and you can see this numbers, and then I can 90 PE, which is called in written is INT P India, and in full form International Professional Engineer India. This is my certificate valid up to September 30, 2025. My professional engineer certificate first was received in 95, then 2012, that was again 2015, and of course 2020 this time. You can see issued on 30th September 2020. Validity of this certificate is only for 5 years. You have to renew, and that renewal depends on success of continuous professional development in your profession, which means in 5 years period you have to get at least 250 marks out of 500 marks, and this depends on your learning during 5 years and your dissemination of information to others during that 5 years, and this includes professional activities, theoretical as well as practical. Continuous professional development is mandatory, and at first time candidate has to appear in written examinations, and after passing those written examinations, 2 papers, one is called for online interview, or you can say video conferencing based interview, and once you qualify all these papers and interview, you can be recommended for enrollment of International Professional Engineer India, and that is part of international body which is constituted based on International Professional Engineers Agreement, which is called IPEA. Previously it was called Engineers Mobility Forum, EMF. This is very significant body because It applies to whole world. This world body of institutions, world body of engineers. There's so many bodies. This is one of them, which gives you International Professional Engineers title. This title means your mobility is accepted with this agreement between countries like USA is a member, USA, England, or UK, or you may say Japan, China, South Korea, South Africa. Likewise, there are currently, I think, more than 15 members. An institution of Engineers India represents India there. Well, it's only for information. Then you have here Chartered Engineer India's title, which is given under provision of the Institution of Engineers India Royal Charter. Members, which is in corporate members here, corporate membership is authorized to use this title, Chartered Engineer India. You may become Chartered Engineer of either division out of 15 divisions. And these 15 engineering divisions, if you qualified, you may be attached to one after you become corporate member, which is associate member, member or fellow. And then it is your fellow, and you can say fellow certificate is also available. You can see that. In this you have to at least have 20 years on an aggregate experience post degree or post qualification. Only then one can be considered fellow, and age should be minimum 40 years. Then we have to think of quality in Bharat, and this quality, as I say, quality in Bharat, India. And my question always remains, currently, where does quality exist? है किधर quality? किधर है गुणवत्ता? Always I say, भारत, इंडिया में गुणवत्ता किधर है? गुणवत्ता कहाँ बैठती है? अभियंता वर्ग में कोई भी गंभीरता देखने को नहीं मिली। कि गुणवत्ता को कैसे प्राप्त किया जाए, कारण मुझको पता नहीं। बाजार में कोई भी पदार्थ गुणवत्ता द्वारा बनाया गया नहीं दिखता है। गुणवत्ता प्रमाण पत्र पर, असलियत पर नहीं, प्रमाणता पर है। एक सामान्य सी प्रक्रिया बनकर रह गई है। प्रमाण पत्र क्या काफ़ी है, हमको सोचना चाहिए। Is having quality system certification enough? Everybody has to think. If certificate provides quality, then it's best way, but that is not fact of life. What I say, it is product that forms quality. It's no certification. Yes, certification acts as announcement that we are well to do and we are qualified enough to provide quality products, but it doesn't mean that product has quality, and that is what system says. System says that my body is strong, my health is strong, but I sleep all time, I do not work. Then how can say that I remain active? It may be government sector or private sector. There is no one to question about power of quality. Says everyone Says everyone that we shall achieve quality and we achieve quality. But I always say, saying and doing are different worlds. You can find many people who go on speaking and speaking and speaking without any final result, without having or giving any conclusive statement. Go on speaking and speaking and speaking and do nothing. What shall you call it? It's only talk, no practical walk. That's what happens in our country. There are so many people who talk a lot, and there are so many people who walk a lot. What class you are? Engineering is different world. In engineering, talks do not matter. Yes, talks matter to some extent for purpose of information and for purpose of instructions, or you can say making specifications. Talks do a little, but constructive. We don't speak like for nothing. We speak point to point, requirement to requirement, define something that should be done, that could be done, that may be done. And after doing, what result we get, that must be analyzed. We generally call plan, do, check, act. It applies everywhere. Every moment you can plan for every minute activity. We can think of that, we can plan that, we can check that, and we can improve that. And that is professional requirement. If we stop thinking, I can say at that point, we are not professionals. Thinking is part of life. Thinking is part of life. Nowadays people say critical thinking. I would say no, it's not critical thinking. First it should be real thinking. What is meaning of critical? We don't think. We don't think even. What are you talking of critical or supercritical? If we think, I think it's best. I can't blame everybody. It is basics of education that must force you to think. It's no need. We have to walk on a line. We call in our language, lakir ke fakir. We cannot move on a fixed line on stones. We have to draw a line ourselves where it is possible. If we want to achieve quality, first we have to achieve quality in individuality. Every individual must be qualitative. Education should be based on that. If we don't have quality in individuals, we cannot achieve quality anywhere. Education should be constructive, should be informative, should be realistic, should be traditional, occupational, vocational, and professional. I have seen many people who have never gone to universities, to colleges, to schools, to learn any technique, but they are masters in technology by virtues of family or clan-based experiences, traditional experiences. Those people act as if they are born with that technology, and I have seen such engineers, such people who look to be born as such, which means maybe I can't say they have past and past and past experiences in life, but there are people who are very well educated in current education system, but if you compare their working, they do not give any result. There are people in every branch of engineering, in every branch of non-engineering. There are people who are just book born and not work born. I don't say book born is bad, but book born means you must have practicality of what you learned. If your education does not provide working environment, working philosophy, working creativity, this means education has got certain deficiency and that must be relooked. We cannot evaluate only certificates. We cannot simply say this person has this certificates must be considered expert. No. You can be considered experts only when you have proven your capability of doing something. Engineering is that world where facts are considered, no fictions. In engineering, if fictions are considered, that are analytical. In analysis, we can think whatever we do, but results should be based on facts. We can assume, we say, okay, let us consider this. At every step in derivation of formula, we say, let's consider this, let's consider that. That is factual or non-factual, that depends on situation. But that is imagination. We imagine, for example, okay, there is a beam, there is load on that beam, that load is imposed on beam. You know what I mean by beam, a horizontal member. Load is imposed on that, load acts on that, and beam sags, or we can say deflects. When we remove load, it goes back. It goes back to its original position or permanently deflected position after having some recovery of deflection. That is imagination, because no beam does as such. Practically, we control it. We control it by whatever technology, that's different. But it's a part of imagination, it's a part of speculation, you can say. We can say engineering is based on practical speculation based on theory. And that theory is analysis based. And once we understand analysis and result of analysis, then we can combine those various analysis results and we can say, okay, this is what one formula or a sequence of formula. That's where it's done. And because it is quality analysis, it is quality analysis. It's not just analysis. It is relevant analysis. Therefore, I can say analysis is extremely important in engineering. We have subjects like this, particularly in civil engineering. We have theory of structures, and we have applied mechanics, we have strength of material, we have structural designs, all we have. These are all high power mathematical subjects. Strength of material, what is that? It clearly says what is power of that material we talk of. And it's very disruptive. We have to see every material, whatever we have. Every material in natural form or material that we create artificially, we have to evaluate, we have to understand, and we have to review, and we have to decide what percentage of its capability we can use in our theory of structures and designs. We have applied mechanics, which is different kind of subject, but directly applicable to engineering. It's mechanism. How do we use it? That's why I call it applied mechanics. Generally, applied mechanics and strength of materials are linked together. Then we have at higher level theory of structures. Just it says theory, and we understand what is theory, origin, understanding, original understanding of structures. And there are many kinds of structures we use in our engineering. And this structure doesn't mean only civil engineering structures. I'm talking of civil engineering, but structures exist everywhere where no forces work. For example, you can say structure in writing, structural in society, structural constitutions, different type of layers, you can say, different type of hierarchies, we can say. What I'm talking is for engineering. And the structure means complete anatomy of that design. Just like we have a body. We have a body we live in, and this body has certain structure which called skeleton based on anatomy of body. So we can say if our structure is not good, we can't live. Same way, if structure of certain unit, certain building, or some other useful item, useful product scenario like bridge, flyover, dam, building, or whatsoever. If structure is defective, is not completely performing or motive, then we can say this is dangerous. This can yield whatever time, either with warning or without warning. That's where it's important point. Structure is important, or its finishes are important. Everybody would say structure is first priority because based on this, everything else stays successfully or relies whole life upon. That's why I say when point of quality is raised, point of quality is considered. It doesn't mean that quality system we talk of in construction or manufacturing. We talk of that system in designs itself. First requirement of quality is in designs. The design itself is very wide spectrum, very wide, you can say, field, and whole life you cannot learn everything. Same way I say design must be given proper attention because something we use for whole life or more than whole life. A structure can be used by many generations. It's not only for one generation but also for generation to come in. If say structure says works for 100 years, just assume in 100 years if you spend 6 months or 3 months in details on designs, just to decide what's best one, what may be best one for this structure, because it's going to stay in 100 years for 100 years. We should not be in panic to design, or care to design in 2 days or 3 days. That's what I'm saying. We have to allow time for very basics activities like designs. To understand what structure says, how does it talk to me? How shall it talk to those who use it? That's where point says clearly. Civil engineering is not very fast moving world, but we have made it fast moving world because of, you can say, skyrocketing technology, or you can say fast construction. Construction has to move fast, but we should not forget, fast doesn't mean bad quality. We can be fast, we can be rapid, we can be very fast. People so-called fast-track construction. Yes, fast-track construction. It doesn't mean bad construction. It doesn't mean substandard construction. That's why I say it's not certification requirement. It's work requirement. its quality requirement, its responsibility requirement, and that is where engineer has to answer. गुणवत्ता प्राप्त प्रमाण पत्र असलियत पर नहीं बस एक सामान्य सी प्रक्रिया बनकर रह गए हैं। सरकारी हो अथवा निजी हो, गुणवत्ता सब जगह होनी चाहिए, पर है नहीं, और कोई प्रश्न करने वाला भी नहीं होता है। कोई किसी को भी चिंता नाम की चीज़ नहीं है, परंतु उत्तरदायित्व किसका होता है? अभियंता का। पर क्या अभियंता जानता है कि गुणवत्ता किसे कहते हैं? ये मैं नहीं कह सकता, लेकिन वास्तविकता यही है। शायद अभियंता भी गुणवत्ता को भूल चुके हैं। और क्या हम लोग बिना गुणवत्ता प्राप्त किए उन्नति कर पाएंगे, या सपनों की दुनिया में ही विकास करेंगे? बहुत बड़ा इशू, क्वेश्चन। हमारे यहाँ हजारों लाखों अभियंता। In our country we have millions and millions engineers, and there is no dearth of civil engineers, no dearth for mechanical engineers. There is no dearth of any class of engineers. Despite this richness, I think it is nothing but carelessness. It's nothing but carelessness, or you can say ignorance. No answer can be given. No answer can be given. Just like now, video and signals are down. 0, 0. Nobody can answer. No one can answer to someone who is ignorant or who is careless, who does not attend to do job, who takes every act normal, and result is always bad. To my understanding, engineering is very serious world. It's not for entertainment. It's not for money making. Of course, money is involved. Without money, engineering cannot be done. And particularly civil engineering, or you can say construction engineering or design engineering in civil engineering, are very serious world activities, world objects. Maybe people are not aware. In general, in our general community, everyone doesn't know, I think, except those who are designers and engineers. Others do not know what we do in designs. It's not secret, but people are not aware of. We, in designs, we calculate each and every member and each and every force that's applied to member. And member itself is a force. Every part of structures, every part of steel bar, every part of steel, structural steel, is calculated. How shall force act on that? And all forces, not one, not two, whatever force that can impact, that can impose on this structure throughout its life, are calculated, are considered. Of course, this is calculated effort. All forces are worked out, these forces are applied, of course imaginarily, not practically, but based on formula. and then we get some results, and we call it, this is analysis, result based on provided information. And we can use these results for purpose of real design, which may be RCC design, structural steel design, precast or pre-stress design, or previously which was other designs, light or low level designs. But now we are talking of RCC, structural steel, pre-stress, etc., etc. Every work, every steel part, every concrete member, all are designed in details. And then those designs are finalized and drawings are reported, drawings are drawn, and these drawings are used for purpose of construction. This is only one part. Then construction itself is a different world. Design is one world, construction is another world, but both are blood related, function related. Both are functional related, both are material related, both are soul related. In combination of all this, we can say both are systems related. Engineering, again I say, every time I say, it is facts dependent, facts, certainty dependent. It's not simple theory, and it's also not simple practical. It's combination of theory and practical. That is called engineering. If someone qualifies education of engineering only, some degree or diploma, or masters or doctors, but never works in engineering, never applies that knowledge, that person forgets it sometimes in life. Gradually, that person who doesn't have engineering practice or engineering activities involvement, that person tracks off from engineering field. Just certification doesn't mean anything. Again I say, one must have, as we call, experience of that theory which we learned, and that can be done only in profession or in field of engineering. If we want quality oriented work, then we have to think about this, how we can get it. Can our student be more aware about engineering practice, engineering work, engineering activity? They can be converted to that level only by practical education, not by 5 years field theory. Theory is a requirement, theory is a must, but theory is must only when work is must. Workless experience cannot be called work. Experience cannot be called experience. I know whatever we learn in university is some voluminous books, contents, but these cannot be applied in life all time. For consideration of quality, our goods, our products, like engineering students who become engineers after passing examination, they should be suitable to work, but it's not actually possible because of lack of practical involvement. No one is confident when, after passing examination, one joins any field. That's a fact. That's a fact. Because no experience. One has to learn. The point remains where to learn. Everybody would say you have to learn in field. You have to learn in design work. You have to learn on site activities. But learning what? You can learn only from those who have reliable experience, who have sincerity of activity working, who do work according to design, construction, specification and quality requirement. If you never care for quality, never care for specifications, how can one work? How can say that? Ourselves aware, we have to rise to requirement. We have to be serious in mind. I'm not saying serious in face or face impression, seriousness of mind, and we have to produce such documents. Design people should produce such documents that are real one, that are based on practical experience and theory. Those should be compatible one. We generally call them detailed engineering designs and also working designs, and we also call engineering specifications which are going to be implemented. And if you implement them, and we cannot simply write something which is not going to work, we have to write something that's going to work outstandingly. Therefore, we can say specifications are significant part of quality, because its significance in the sense that if you don't have written information, you don't have written requirement, how can someone working site follow up with that? Because one has to learn, and these writings teach. These writings help everyone learn. Again I say, engineering does not stand at one point. Engineering moves in whole circuit. Engineering moves in whole chain, whole sequence. It's very difficult sometimes to explain engineering. It's very, very difficult. And depends on standards of seriousness. And seriousness means analytical thinking, analytical work, seriousness of approach, and digestion of boredom. Engineering is not entertainment world. It's world that produces sources, that produces assets. Every moment in work is important. We cannot chat for nothing. We have to chat with project. We have to chat with documents. We have to chat with designs. We have to chat with those who are more intelligent than us. And we have to teach those who are inferior knowledge, or who deserve to be learned. They deserve to learn. We have to teach them by demonstration of activities and not by just talking. When you demonstrate activity, facts are known. Time is understood. How many hours this activity consumes. We can say observation. Concentration on observation. Observation on work. It takes time, of course, because here work is professor. Here practical work is professor. We don't need another professor. And we become professor one day. When you work for many, many years on many, many projects, certainly if you do correct job, you want this quality job, one attain some standards, one attain some specialization, some expertise, and that is what you call education on front line. Education in field of engineering not in education of engineering. In fact, that is real education. To do job right and learn yourself and let others learn. And same way, teach your workers. When they see also what they do, they learn too. It's really very important and interesting point, which we forget always. We never give weightage to such points, and that's where we fail. It's what we say, work is professor always, and nothing wrong with that. Work is professor. Or nothing you cannot explain. We're talking of concrete. We're talking of concrete, and this was somewhere we had gone through concrete specifications. Which we're talking is Qatar specifications we did, and I think it was an interesting one. In fact, this specification myself was surprised one time that when I worked there in Qatar, I did not have all this information in those specifications. I did not have all this information, and then I can see that it was Qatar national building specifications that time, but now these specifications when I reviewed by downloading, and I saw there much addition onto this. I appreciate that with use time onwards these specifications are updated, and it's really helpful. I'm not saying these are perfect or no perfect, but we can say specifications. We should respect this. If there's update on information, I seriously try to learn based on this specification as well as specifications used in UAE, particularly on oil projects. Specifications are very tough, very difficult, but without that we can't move. So learning in field, well, I think is very wide university. It's not formal one, but it's work-based one. What sometimes you learn in field, you may not even find in your books, not at all. This is a problem in engineering. You cannot just refer to book, academics particularly, and say I learned it, because that's old one. Technology reaches book only once it is old. And what you learn in field and construction field is tremendous update. We have to refer to codes, we have to refer to specifications, we have to refer to update all time, and of course documents that we have in field, and particularly on contracts. You may work either way, on behalf of contractor or on behalf of engineer. Whatever way you work, you have to deal with those documents. Those who are in designs, who work in designs, they too have same exposure, because working in design is also not easy. I have seen difference in capacity of engineering professional. They think that design is only calculation or drawings. They miss some time which others may not. Specification part of designs, I'm saying particularly specification part of designs, because specifications writing decision of specifications amounts to first work in design. Your structural calculation comes later. If you do not know materials that we are going to use, if you cannot specify those materials elaborately, how can we consider designs? How can you include that material in design? You may say primary specifications, general specifications, or particular specification. We have to consider like this. If you do not understand impact of specification, how shall those who work in field on sites at end, you think they search for your specifications? No. Until they are forced, they won't search. They won't like to study that, because young people wants to push everything very fast. Young engineers wants to show they are very efficient, but they forget only pushing a project rapidly minus quality achievement does not mean work. I'm not saying it doesn't happen. It happens where seriousness exists. Quality cannot be kept in isolation. No one can claim I have worked only with quantity and not quality. If one states that, I cannot call that person engineer. I cannot call that person worker. I cannot call that person worker or engineer. Quantity and quality, again and again I stress, are united. You cannot separate quality from quantity. No one can separate it. Something is specified indicatively and something is naturally available, which means whatever is naturally available, that cannot be isolated. That cannot be called differently. We have to understand this. I stress on concrete. Concrete, which is, you may say, exclusively reliable material, without which we cannot move forward, without which we cannot do anything. This is current scenario, and this has been for many decades. Power of concrete. Concrete makes us. Concrete builds us. Concrete develops everyone. Concrete means strong material. Concrete means solid decision. Concrete means heavy, powerful. We cannot say concrete can be avoided. Cannot say that. I'm not talking of construction alone. I'm talking of everywhere. Without foundations, without good structure, nothing can work. Foundation is a structure, part of structure. Foundation, or we say substructure, means structure below ground. When you say structure below ground, it can be every ground, not only site ground or construction ground. It can be every ground. What I am saying is, we have to establish something. Establish this institution. It's called institutionalization. We can say engineering is also an institution. That way. Because every act in engineering is very systematic. We cannot do it without system. If you do it haphazardly, this means we have no system. We have not contemplated. We just move blindly and we don't even understand what we did for that. Engineering requires complete structurization, complete structural network. Of course, it looks a little difficult, but once we establish some system, then you can say it's fine. In every sphere of life, it is done. Maybe not indicatively identified, but it is conducted. Concrete, as I said, is powerful material. Material in a sense, it's not available ready-made. We have to manufacture it, or we have to process it based on whatever ingredients we involve. We include that material. Concrete is something we cannot avoid, and we have to understand this point. And particularly in construction, in development works, every development works, to whatever level it is, somewhere it is included permanently. It's included permanently in such a way that it becomes our building member. There may be many types of structures, we know. It may be building structure, it may be some plant structures, or it may be unplanted structures like irrigation network, like dams, where structure is important, not its processing, and where plants are involved, where structure as well as processing both are integrated, both are as significant as you can say respiration or breathing in body. I'm sometimes different in my approach because thinking makes you such a powerful person. Keep on thinking. I am sure if you continuity of thinking empowers you to think more and more, and that's really, you can say, mind opens. Mind helps you continue thinking, not just critical thinking, because thinking itself is critical. Critical means you have to handle every case, every point, every problem based on your analytical mind, or you can say brilliance of mind. Brilliance of mind. Only powerful tool God has given to everyone is this equipment. Equipment supported by whole structure of body, and that equipment is mind. I can say that engineering is mind. Engineering is use of mind, or you can say engineering is controller of everything if we really do engineering. I try to stress because engineering is not a profession itself. You cannot call engineering alone a profession. No. It's your life. It's your life. Realization may be affected, but fact remains. Whoever you are, whatever you are, whether you are not concerned with engineering, but engineering is concerned with you, that point we have to realize. And that is my point, that is my focus, why I decided to conduct very small talk every day. And this talk is around engineering, and engineering means society. Engineering means everybody moves itself based on certain requirement, certain necessity. Everybody is involved. Civil engineering, we call it very common one because it's for people, all people of world. I'm not saying civil engineer means learning a lot of money earning. No, I'm not talking of money earning. I'm talking of money investment, money spending. When we think of making a house for ourselves, it doesn't happen in one day. You cannot say decide today and get a house. You can't say that way. Because house is such an item that takes time for design and construction, and it depends upon your capacity, how much you can have it. And you feel very celebrative when you see you have done it, because you have made your forthcoming future to that destiny, into that destination of your building your house, and which is very combined material, composite material. And how can you accept bad? You cannot accept in bad quality. When we talk of concrete, we talk of technology. It's not brick, it's not simply stone, it's not simply cloth. It is something which must be given required concentration, because concentration is free of cost. Nobody pays anything for concentration, just like we do not pay anything for thinking. And for me, thinking is God's gift. It's not just to eat and sleep. Thinking is your friend. Thinking is your best friend, because as much as we think, we get more and more sharpened in our mind, and that sharpness is self-teacher. That sharpness is self-announcing. Concrete is like that. Though we say it's material, it's not simply material. It's a functional material. When ingredients of concrete are put together, mixed together, and used, these work as artificial stone at final level. At end day of, when we say, okay, today its final strength is this much, and that strength works for many decades to come if work is done properly and maintained properly. World uses earth. We all use earth resource, earth source, because we cannot take it out and you say this is for my portion, this is your portion, cut out and use it or eat it. That's not going to work. As I said, in concrete, we talked of long list of properties till yesterday. Now it's polished resin concrete, piping systems for non-pressure drainage and sewerage. In general, it says polished resin concrete, which is a mixture formed from aggregates and fillers, which are bound together using a polished resin, also called polymer concrete pipes. As defined in ISO 18672 RSTMD 76783, the polished resin concrete is a mixture formed from aggregates and fillers, which are bound together using a polished resin, also called polymer concrete pipes. Polished resin concrete is permitted for use in infrastructure, drainages and sewage system, pipes, manholes, soakways. Resin. Resin used in pipe system. Resin used in pipe system and manufactured per ISO 18671 shall have a temperature of deflection of at least 85 degrees Celsius when tested in accordance with method A of ISO 75-2 with test specimen in edgewise position. It shall conform to apply applicable requirements of ISO or EN 13121. Well, I repeat, it says polyester resin concrete is permitted for use in infrastructure, drainage and sewerage system, that is pipes, manholes, soakways, and resin used in pipe system and manufactured as ISO shall have a temperature of deflection of at least 85 degrees Celsius when tested. Resin used in pipe system. Resin used in pipe system and manufactured shall have a minimum deflection temperature of 85 degrees Celsius when tested at 1.82 MPa. Following test method D648. Resin content shall not be less than 7% of weight of sample as determined by D2584 test method. Minimum strength classes for different types, different pipe shapes are given below. What does it say? Minimum strength class of pipes. It is polyester resin concrete PRC piping system for non-pressure drainage and sewerage. Non-pressure drainage and sewerage polyester resin concrete. So that's what say minimum strength class for pipes. Minimum strength class for pipes. This is designated PRC C or PRC TC. Now it says nominal diameter, then strength class SC, say concrete pipe system or non-pressure drainage service. Non-pressure means NP. So here is that nominal size diameter, then strength class SCN per millimeter, and nominal dimension sizes. Now it's between 150 and 500, then it is 600 and 1000 and 1200 and 3000. PRCOC and PRCTC. Newton per millimeter is given in PRCOC 180 to 120, and then PRCTC is a little different. Minimum strength class for pipes, it is same way designated as such. It is PRCOE, PRCTE, and it is 300 450 up to 600 900 likewise, and 700 1050 to 100,000, 1000 1500 likewise, and also nominal size and strength class are given differently. Now we go to structural precast concrete. Structural precast concrete. You know precast. What is precast? Precast and cast in situ. Everybody knows what is cast in situ because everybody watches when concrete mixing goes on and people collect that concrete and use in their building. That's called cast in situ, and even if it is applied from, it's delivered by batching plant, same delivered to site, and you have to use it, include this. Casting on site is called cast in situ. Casting off site or casting somewhere in the yard, it's precasting we call it, and designs are different. Pre-stressed concrete has complete different world of designs. You can say in structural precast concrete, general it is scope, reference, submittals, quality assurance, before that qualifications, and quality control, testing, delivery, storage and handling, design loadings, actions, and structural members selection. In that material, that of course you can say that this is structural precast concrete. The materials we have general, reinforcing bars, bearing pads, embedded steel, then form, general tolerances and installation, that is general, survey, guying, bracing, ensuring, adjustment and correction, erection, tolerances, welding, grouting, field cutting. Very small it is. Structural precast concrete. Structural precast concrete we call it. And you can say work included herein comprises furnishing all plant, workers, equipment, appliances and materials, performing all operations in connection with structural precast concrete work. And we can see sections that relate to this in this document. In these specifications are aggregates, cementitious materials, admixtures, property requirements, concrete plants, transportation and placing of concrete, formwork, curing, reinforcement, hot weather concrete. Standard specification of highway bridges, guide for precast silver concrete, floor, roof and wall units, guide for precast concrete wall panels, design responsibility for architectural precast concrete projects, design, manufacture and installation of concrete piles, guide to evaluating cast in place detailing for seismic design of precast concrete members structures, minimum design loads for buildings and other structures, building code requirements for structural concrete, structural use of concrete, and Euro Code 1 actions on structures, general actions, wind actions, and you can say Euro Code 2 design of concrete structures, general rules and rules for building. Quality organizations for system, fundamentals and vocabulary, Police Institute. Now, let's say talk of precast concrete. We can think it in the same way. We can say that contractor shall, we're talking of submittals, contractor shall submit copies of manufacturer's specifications, installation instructions for each item or proprietary material to be used, showing compliance with this specification. Information or equipment. Information or equipment, embedded items, and other accessories shall also be provided. Design mixes, copies of mixed designs with support materials and requirements of mixed design shall be done in accordance with can say that compliance with the specification, information or equipment, embedded items and other accessories shall also be provided. Design mixes, copies of mixed design, support material, requirements of mixed design shall be in accordance with part 6 and 7. Then we can say product design. Initial handling and erection stresses. All the live loads as specified, specified on contract drawings or as required. All other loads specified for members where they are applicable. Product design calculations. Product design calculations. Calculations shall be performed by a structural engineer experienced in precast concrete design. Cover all stages of handling, transportation and erection. Shall be carried out in accordance with requirement of codes, BS or ACI, and accepted by an engineer. Calculations for designs of precast members shall be supported by a statement explaining principle of design and type of analysis adopted. Influence of individual members in achieving the overall stability of structure shall be fully described. Computer programs used in designs shall be fully described. Computer programs used in designs shall be fully described, and details of input computer programs used in design shall be fully described, and details of input and printout shall be presented in manner which can be readily understood and following requirements be met. Program manuals and instructions to program users shall be made available to engineer upon request. Where such program cannot be demonstrated by contractor to have been fully checked, or where engineer considers it necessary, contractor shall provide or shall run such test examples as engineer may choose in order to verify completeness and accuracy of program. Members that are exposed to weather. Members that are exposed to weather shall be designed to provide for movement of components without damage. Failure of joint seals. Undue stress on fasteners or other detrimental effect. When subject to seasonal or cyclic daylight, day-night temperature ranges, precast systems shall be designed to accommodate construction tolerances, deflection of other building, or can say members that are exposed to weather shall be designed to provide for movement of components without damage, failure of joint seals, undue stress on fasteners or other detrimental effects, and subject to seasonal or cyclic daylight temperature range. Precast systems shall be designed to accommodate construction tolerances, deflection of other building structural members, and clearance of intended openings. Calculate structural properties of framing members in accordance with BS 1110, 8110 or BS EN 1992-1-1 or relevant ACI codes. Shop drawings. Contractors shall provide following information for approval by engineer, that is layout plans and detailed fabrication and placement drawings for each structural precast element. Shop drawings are to include following information: the size, grade, profile and dimension of material used, connection and anchorage details. Shop drawings have to describe size, grade, profile and dimensions of all materials used. Connection and anchorage details. Lifting devices, locations and handling limitations. Steel reinforcement details, all openings, sleeves, inserts and other provisions in full coordination with all trades in contract. Identification marks, erection procedures. Erection procedure, detailed outline of sequence and methods of erection, including but not limited to types, capacities and numbers of cranage, methods of support and transportation. Fabrication records. A record shall be kept. A record shall be kept. A record shall be kept for every piece of precast element produced, showing following: type and number, date of pour, concrete test results, shop drawing reference number, type and duration of curing, date of delivery to site, date of fixing in position. Test reports. Copies of all testing and inspection reports, trial panels. Contractor shall produce trial panels in accordance with requirements of Part 10. Trial panels shall be retained for reference purpose for acceptance of production work. Qualifications. Structural precast work shall be executed by an approved specialist subcontractor for casting and also for transportation, handling and erection. Structural precast work shall be executed by an approved specialist subcontractor for casting and also for transportation, handling and erection. Contractor may execute this work self if one can satisfy engineer that he has sufficient experience and expertise in field. As minimum, contractor shall provide satisfactory evidence that tradespersons and their supervisory personnel engaged in such work have successful experience with work comparable to that shown and specified. Provide details of organized quality control and testing procedures. Quality requirement assurance. Precast concrete supplier shall have to have a quality requirement assurance system, that means ISO 9000, all work shall be performed to secure for project homogeneous concrete having required strength, surface finish, materials, durability and weathering resistance, without plans of weakness or other structural defects, and free from honeycomb, air pockets, voids, projections, offset of plan and other defacement of concrete. No, you can say, work shall be performed to secure project homogeneous concrete having required strength, surface finish, materials, durability and weathering resistance, without planes of weakness or other structural defects, and free from honeycomb, all perfect, all legislative body we can say weather resistance, without planes of weakness or other structural defects, and free of honeycombs, air pockets, void perspective, offshore plans and other defacement of concrete. No alteration or substitution of structural system shown on drawings are permitted unless otherwise specified. Contractor shall supervise and coordinate all phases of structural precast concrete construction process and be responsible for complete manufacturing process. All methods of manufacturing practice of handling raw materials and manufactured concrete. We say All methods of manufacture and practice of handling new materials, raw materials, manufactured concrete shall be reviewed by engineer before execution of structural precast concrete work. At least 14 days before beginning of precast work. Only materials for known quality shall be incorporated in works. All materials shall be properly selected, reviewed and approved by engineer before use and maintained during shipment, storage and use. Techniques shall be properly selected, reviewed and approved by engineer before use and maintained throughout complete structure precast concrete member. Concrete phase. Concrete construction system and technique shall be properly selected, reviewed and approved by engineer before use and maintained throughout complete structural precast concrete construction phase. Adequate spare equipment, parts, additional components and repair facilities shall be available for all tools and equipment. Regardless of approach by engineer, contractor shall be responsible for all materials and methods of structural precast concrete work. If work does not meet, it says regardless of approvals by engineer, contractor shall be responsible for all materials and methods of structural precast concrete work. If work doesn't meet specified requirements, contractor shall at no additional cost to employer implement removal, replacement or remedial work. Revise procedure or materials to prevent recurrence of unacceptable work. Quality requirement. We call it quality control here. Quality control. Contractor shall prepare and provide its quality control program for structural precast concrete work, with particular attention to detailed pre-checking processes, procedures and close supervision. Contractor shall arrange for training, contractor shall prepare and provide quality control program for structural precast concrete work with particular attention to details, pre-checking process, procedures and also continue to extend. Contractor shall prepare and provides quality control program for structural precast concrete work with particular attention to details, pre-checking processes, procedures and close supervision, and in particular contractor shall, in order to ensure that proper work is performed to prevent later corrective action, assign at least one experienced supervisor full-time to provide quality control for structural precast concrete work. Assignment shall not relieve contractor other quality control personnel of their duties relative to quality control of structural requirements and surface finish of structural precast concrete work. Again I say, in order to ensure contractor shall, in order to assure that proper work is performed to prevent later corrective actions, assign at least one experienced supervisor full-time to provide quality control for structural precast concrete work. Assignment will not relieve contractors, other quality control personnel of their duties relative to quality control of structural requirements and surface finish of structural precast concrete work. Contractors shall arrange for training of its quality control personnel who perform quality control of structural precast concrete work and whose training includes but not be limited to material evaluation, spatial mix design techniques, mix placement, vibrator selection and use, formwork details, formwork protection, release agent use, reinforcing steel, detailing and installation, finishing equipment and techniques, corrective procedures and protection of completed work. Contractors quality control personnel shall be responsible for verifying all details necessary to produce final structural design organization. Details and installation, finishing equipment and technique, corrective procedures and protection of completed work. So what are these points? Let's repeat. These points are materials evaluation, spatial mix design technique, mix placement, vibrator selection and use, formwork details, formwork protection, release agent use, reinforcing steel, detailing and installation, finishing equipment and technique, corrective procedures and protection of completed works. Vibrator selection, formwork details, release agent, reinforcing steel, detailing and So we can say corrective precision protective a contractor's quality control program or personnel shall be responsible for verifying all details necessary to produce final structure design objectives. Contractors quality control personnel Contractors quality control personnel shall also verify quantity of structural precast concrete work and guide production of results which which shall be within acceptable physical tolerance. Testing. Contractor testing concrete shall be tested as specified, and that is contractor shall furnish workers required to facilitate testing. Inform engineers with at least 1 day's advance notice when concrete is to be placed. Provide storage facilities for concrete test cubes. Provide material submittals and access to materials as required for testing. Should batching plant be located more than 500 meters away from site office? Contractor shall provide suitable transport acceptable to engineers to sole use of engineering staff. Contractor shall station a qualified technician at casting site to continuously test, inspect, and report following. That concrete testing is being carried out in accordance with requirement of Part 6, check following and verify conformance with specified requirements and approved shop drawings, all reinforcing bars, all embedded items, all formwork. Check all openings and provisions for coordination with all traces in contact as shown on approved shop drawing. Contractors shall provide facilities and equipment for conducting of all tests specified herein, except for strength test, which should be carried out by an approved independent agency. Storage and handling. Structural precast element shall be removed from form without damage or even or over stressing and stored or placed for transportation on a stable bed that won't allow distortion of member. Separate stacked members with suitable battens and bracings. Make each member with an identifying reference or piece mark and date of casting. All pieces marks are to be correlated with test ports. Make each member with an identifying reference or piece mark and date of casting. All piece marks are to be correlated with test reports and plan layout of erection drawings. Structural precast element shall be transported with sufficient battens, bracings and supports so as to prevent overstress by vibration or impact loadings. Contractor shall submit proposed method of transportation to engineer for approval. Such precast units shall be stored, handled and transported in a manner that will avoid undue strains, air cracks, steering or other damages. Contractors shall deliver units from casting site to project site in accordance with schedule and proper setting sequence. Structural precast units shall be stored free of ground and protected from wind or rain splashes. Units shall be covered and protected from dust, dirt or other staining materials. During fabrication, construction and after erection, contractor shall protect casting to avoid possibility of damage. During construction, during fabrication, construction and after erection, contractor shall protect castings to avoid possibility of damage. Design, loadings, actions and structural members selection. Design, loadings, actions and structural members selection. Provisions of this clause shall apply if contractor is responsible for serviceability must be measured. Precast elements shall be designed to withstand all loading conditions against which strength and serviceability must be measured. Vertical loads shall include self-weight of precast element, floor coverings and live loads as indicated on contact drawings. Vertical loads include self-weight of precast elements, floor coverings and live loads as indicated on contact drawings. Wind load shall be calculated based on wind speed provided in this section. Vertical, wind loads shall be calculated based on wind speed and it's provided in section 1. This clause is account shall be taken of loads and deformation. Account shall be taken of loads and deformation caused by temperature and time dependent deformations. For such purpose, 55 degrees Celsius temperature variation and 90% relative humidity should be considered for all members except exterior elements and facade elements shall considered 85. Account shall be taken of loads and deformation caused by temperature and you can say account shall be taken of loads and deformation caused by temperature and time dependent deformations. For such purpose, 55 degrees Celsius temperature variation and 90% relative humidity should be considered for all members except exterior elements and facade adjacent. Relative humidity should be considered for all members except exterior elements and facade elements shall be 85 degrees Celsius. Precast elements shall be designed in accordance with BSCN 1992-1-1 or relevant ACI code. Design tensile stress should not exceed design flexible tensile stress of concrete at particular age of concrete. Nominal cover to steel. Nominal cover to steel including links. Nominal cover to steel including links must meet durability requirements. Nominal cover to steel including links must meet durability requirement of severe conditions of exposure, and nominal cover to steel including links must meet durability requirement of severe condition of exposure and to meet requirements for 2-hour period of fire resistance as provided for in this code. Total deflection of precast elements should be limited to 1/350 span of this element. Plan and design of openings should be limited to 1/30 of Plan and design of opening for building services where required or necessary. Total deflection of precast elements should be limited to 1/350 of span of element. What are materials now? Materials. General. Contractors shall obtain contractor shall provide all material in accordance with meet all applicable requirements of this section. Reinforcing bars. Reinforcing bars shall conform to requirements of Part 11. Bar, we say reinforcing bars shall conform to requirements of Part 11. Bar bearing pads. There, these shall be elastomeric. This shall be elastomeric neoprene conforming to ASTU standard specifications. Elastomeric neoprene conforming to ASTU standard specifications for highway bridges with following stipulations. Use unfactored loads for design. Maximum compressive stresses 0.7 MPa. Maximum shear stress 0.07 MPa. Maximum shear deformation 1/2 thickness. Maximum compressive strain 15%. Embedded steel. All embedment members or embedded items shall be stainless steel grade 316. Embedded item shall be stainless steel grade 316L. Now, saying embedded steel shall be stainless steel grade 316L. Forming. Forms and casting beds are to be firmly sealed so as not to deflect or be displaced under concreting or tensioning loads. Forms and casting beds are to be firmly sealed or cast. Forms and casting beds are to be firmly sealed so as not to deflect or be displaced under concreting or tensioning loads. Correct for thermally induced strains or forces. Correct for thermally Forms and casting beds are to be firmly sealed so as not to deflect or be displaced under concreting or tensioning loads. Correct for thermally insulated strains or forces. For members, penetrations larger than 150 mm, coring or field coating is not permitted unless approved by engineer. And then you can say forms and casting beds are to be firmly sealed so as not to deflect or be displaced under concreting or tensioning loads. Correct or thermally induced strains or forces. Correct thermally induced strains or forces. For members, penetrations larger than 150 mm, coring or field cutting is not permitted unless approved by engineer. Clean and coats. Correct thermally insulated strains of force. Correct thermally induced strains or forces. For members, penetration larger than 150 mm, coring or field cutting is not permitted unless approved. Clean and coat forms. clean and coat forms with releases. Yes. Now you say here tolerances. Tolerances. Permissible deviations of formed surfaces are not to exceed tolerances outlined in PCI Manual 116, which items are summarized modified in Table 17.1. Tolerance for structural precast concrete. Length plus minus 5 mm, width plus minus 3, this please minus or yes, thickness stem plus minus 3 mm, flange plus minus 2 mm, embedment or penetration location plus minus 2%, straightness plus minus 3 mm for 300 centimeter, and squareness plus minus 3 mm. Installation. General. Contractors erection responsibilities. Contractors erection responsibilities include safe and proper placing. Safe and proper placing, aligning and leveling of structural precast elements. Installation. Contractor erection responsibilities include safe and proper placing, aligning and leveling of structural precast elements on and on accepted bearing surfaces and affecting their proper fastening. Contractor erection responsibilities include safe and proper placing, aligning and leveling of structural precasting elements on accepted bearing surfaces and affecting their proper fastenings. Contractor erection responsibilities include safe and proper placing, aligning and leveling of structural precast elements on accepted bearing surfaces and affecting their proper fastening. Survey. Before placement of structural precast elements, contractor shall survey and maintain all temporary supports shown are required to control alignment and deflection. Temporary supports shall be retained until framing elements braced thereby have attained integral stability. Shall install in proper sequence and maintain all temporary supports shown are required to control alignment, deflection, and stress levels. Contractor shall install in proper sequence and maintain. Contractor shall install in proper sequence and maintain all temporary supports shown are required to control alignment, deflection, and stress levels. Temporary supports shall be retained until framing elements braced thereby have attained integral stability in accordance with design. Adjustments and correction. Contractor shall and correct compensate and correct for misaligning effect of temperature, draw from welding, bolting, or erection sequence or grouting. Erection tolerance. Following erection tolerances shall apply unless otherwise specified in contract. Variations for plumb 6 mm in 6 meter run, 1 mm in 1 meter. Variation longer run. Variation from level 6 mm in runs, 6 mm in runs is 12 mm in 12 meter run, maximum 12 mm at control of heat buildup by limiting voltage, electrode size and rate spalled or heat damaged concrete around well windows shall be used. Control of heat buildup by limiting voltage, electrode size and rate, spalled or heat damaged concrete around weldments shall not be accepted. Grouting. Joints, gaps and connections. Joints, gaps and connections shall be filled. Now grouting. Joints, gaps, and connections shall be filled with grout as shown on drawings and approved by engineer. This is grouting. Then field cutting